Hello and welcome to our video on IPC, or Inter-Process Communication. The IPC is essentially how two programs can communicate with each other. So we're going to look at the different ways of performing inter-process communication, and when it's used and why we would use it.
The first thing that we want to talk about right off the bat here is what is a process? A process is nothing more than an instance of a currently executing program. If you take a look at our little thing down here, we have our little computer that's controlling a application called program.exe, and that is the process. Now there's another side of this, and that's a thread.
And what is a thread? A thread is the result of a program forking a currently executing program into two or more concurrent tasks. A program will have tasks that need to execute independently, so those tasks can occur, many of them at the same time. So a program will generate many threads to execute tasks. And this process is basically called forking, the spawning out of child subprocesses called threads.
One thing that's really important to understand about forking and about threads is that this wasn't always there. This is something that kind of came along once computers began to multitask and you could run more than one thing at a time. Because what you can essentially do is take one program and have that one program spawn out into many different types of tasks. Like, for example, a socket a lot of times is running as a thread. Because if you don't run a socket as a thread, then your program is stuck in an infinite loop of listening and it can't do anything else. So what you would do in that instance is you would make a program that spawns off a thread, and then your program then jumps off and does something else while the thread sits there and listens.
Right. So a very basic example of this is if you had a web browser. And every time you click a link, from the time you click the link until the time the web page is fully downloaded, your browser would freeze.
Or your computer.
Or your whole computer would freeze. You couldn't move your mouse, you couldn't do anything. You would just sit until it fully acquired the response from the website, and then it would continue.
So let's kind of talk about this inter-process communication thing. Brian kind of gave a little bit of an overview in the beginning, but it's really a method used in software development to allow processes running on the same or different computers to communicate with each other. And here are some of the basic methods of inter-process communications.
So we have a file as a means to communicate between processes, database, a signal or an event, or a network socket. So in the case of the file, we have multiple processes and threads that all refer to the file system to send messages to each other. So as you can see in this example, we spawn off program 1, and program 1 writes to file.txt. Then program 2 reads from file.txt. So now what program 1 has delivered to the text file, program 2 has read from it. This also works in a larger sense in Linux operating systems, where a lot of the information of the operating system's status is stored in a virtual file system. A lot of times in Linux you use a file method for inter-process communication, but they're not actually files the way that they would be in Windows. The files don't necessarily exist. It's sort of a virtual file system.
I think that's called the proc file system.
The proc file system, exactly. And it's a lot faster than reading and writing from the hard drive.
Next, we're going to take a look at databases. So multiple processes can share information based on a single point of data storage. Now, you could make an argument that this definition fits a file. And you could technically be correct because, you know, from a technical sense, a text file can be a database. Technically.
Yeah.
But the difference here is...
so can a hard drive.
That's true. That's true. But the technical difference here is that a database uses a database management system, which is usually a piece of software that is a layer that runs on top of the database that controls grabbing, storing. It also controls simple things like locking of the database, and, you know, if multiple things are coming in at one time, it controls that flow. So there's more intelligence in a database than with just a regular text file. So here's an example, and it's very much like the file example. It's just that we're pulling from a database. So the computer spawns program 1 and program 2, and program 1 sends something to a database, then program 2 retrieves something from that database. So effectively, these two programs were able to communicate by using the database as an intermediary. There's also a different database communication model, and this is a remote database.
This is similar to our last example, but the database is not on a local file system. So let's walk through this. The computer on the far left executes program 1, so that program1.exe is now running as a process. That process will send a request through something like the internet or a network or whatever, some unknown system, which finally makes it to database service.exe, which is a process running on another computer. That database service.exe is running on a server that communicates to the database. So the request from program 1 goes through the cloud to DB service.exe and writes to the database. Now another computer executing program 2 sends a request through a different cloud or network or internet or anything to the server, to DB service.exe, sends the request, is written and processed to on the database, and a response is set from the server, DB service.exe, back to the requesting system. This is effectively the same way that the two programs access a file, or the two programs access the database, but instead of having the operating system manage how to access the file, it's another computer considered to be a server somewhere else on a network.
So when you have your phone app that checks the weather for you, this is what's happening.
Absolutely.
Your phone app is going to a database and just pulling data, but that data gets sent there by the local weather systems from the different cities that are reporting the weather. The next form of IPCs that we're going to talk about is a signal. A signal is really nothing more than a message that is sent to a process to notify it that an event has occurred. This also fits in with the concept of interrupts. An interrupt signal is sent to the program, which means when an interrupt signal comes in, it stops doing what it's doing. So everything that it's doing, it says, whoa, whoa, stop, signal's coming in. Then it takes a signal and interprets it before it continues, whatever that signal will be. Now, for a lot of you guys, you'll be most familiar with the SIGINT signal, which we know as the control break or control C sequence. This is a sequence or a signal that's used to terminate a process. So when you write a program and it's running, or when you're running a program from a command terminal and you do control C, the program will just kill. Control Z is a similar type of thing, except for it doesn't kill the process, it pauses the process.
So another type of inter-process communication method, which is similar to a signal, is an event. The difference between a signal and an event is that an event does not necessarily interrupt the flow of the executing program, but that request is still queued up and can be accessed by the program. Common examples of an event is a mouse click or mouse movement, keyboard buttons being pressed, a new file being created, a TCP message received on your network card, or mouse hover over. So in these cases, you have an event that happens. That event happens regardless of where the program is running and what state that program's running in. When the program gets to a point where it wants to know what events are pending, it will go and ask and find out what events have happened and handle them accordingly. Here's an example of an IPC method with a network socket.
Now, this kind of differs from the database example in a very fundamental way, because there's no intermediary. What's happening here is we're sending a transmission over some sort of a network protocol like TCP, IP, and we're sending a message to a server program that will respond back to you with a response. So in this example, our computer is running client.exe. And we're going to send a message to server.exe that's asking how much money is in my account. So we're checking our bank account. Now, server.exe does what it has to do to get the information, and it tells Brian that he has 37 cents in his account.
Which is great, because that means I didn't overdraft.
And that's the most money I think you've ever had in your account
Probably.
at one time.
So thanks for watching.